So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. Welcome to lecture number 17 of the binary tree series. We are going to solve the problem of finding the lowest common ancestor of a binary tree, right? So as you can see, the problem says that you have given a binary tree. This is obviously the root of the binary tree given to you. Along with this, you are given two nodes. Suppose the first node given to you is 6 and the second node given to you is 8. You have to find the lowest common ancestor of this. Lowest common ancestor, what do I mean by lowest common ancestor? So we know about the children, that is 1 is the parent of 2 and 3, 1 is the parent of 4 3 is the parent of 4 and 5, 5 is the parent of 6 and 7, 7 is the parent of 8, right? We know about this. Now when we say that 1 is a parent of 2 and 3 and 3 is a parent of 4 and 5, can we say that 1 is the ancestor, or we can say grandfather, 1 is the ancestor of 4 and 5, right? So anything that is connected to 1, that is 1 connected to 2, it is the parent as well as the ancestor. 1 is the parent of 2, 1 is the ancestor of 2. Okay, 1 is the parent of 2, 1 is the ancestor of 2. That is, if we are going from bottom to top, and if the path says that 1 is actually connected to 8, then 8 is also the ancestor of, or 1 is also the ancestor of 8. I hope the definition of ancestor is clear to you, right? We have to find the lowest common ancestor. Now what do you mean by lowest common ancestor? For example, for the given node 6 and 8, if I try to see that what are the ancestors of 6? Ancestors of 6. So 6 ancestors is 6 itself. 6 itself is also ancestor of 6. 5 is ancestor of 6. 3 is ancestor of 6. And 1 is ancestor of 6, right? 6, 5, 3, 1. Similarly, 8's ancestor are 8 is itself ancestor of 8. 7, 5, 3, 1. 7, 5, 3, 1. That is the path we are following are this one and this one, right? Now the question wants us to answer the first node which they are common, the first node common to them, that is, you can see 5 here and 5 here and 5 here. That is, my answer to this problem should be 5, the first node that is common to them, that is common to the ancestors. That 5 is common here, 5 is common here, obviously 3 is also common, 1 is also common, but the lowest common, the definition lowest common says that 5 is the answer, right? Otherwise the first, if it does not provide the word lowest, then 1 is always the ancestor. 1 is always the ancestor because 1 is the ancestor of all the nodes, right? 1 is always the answer. The lowest provides the distinction of finding the 5. Now how to solve this problem? We will just brainstorm some of the ideas to get to the observation, right? Okay, so obviously we are given with the root, so we will have to process the root only. We will have to process the root. Now how should I process? Obviously I said that whenever the binary tree occurs, whenever the binary tree problem comes, we have to go through traversals. We have to go through traversals. Number of traversals, like pre-order, in order, post order, and level order, and vertical order. Vertical order, right? We have not discussed vertical order, so vertical order is obviously not going to be the answer to this. That is, you can apply your mind also. Talking about the level order, can level do anything about it? Like, it can be also possible that uh, if I try to extend this tree, 6 is not here suppose, and 6 is here, and 7, and I try to find the node for 7 and 8. So level order will give 7 and 8 here, 6 and then 7 here. You can see that 7 is the ancestor of 7 and 8. No, right? No. So level order is also not worthy of it. Level order is also not worthy of vertical, also gone. So we are stuck with the 3 standard traversal: pre-order, in order, post order. Which one should I use? Which one should I use? So if I try to think that if I go to 1, if I go to 1, 1 can go to 2 and 3. 1 can go to 2 and 3. 3 can go to 4 and 5. 3 can go to 4 and 5. 5 can go to 6 and 7. 5 can go to 6 and 7. 7 can go to 8. 7 can go to 8. Now I can go in the top down fashion. This is top, this is down. But can I do anything with a top down approach? Can I do anything with a top down approach? I don't think so. I don't think so, because at last my driver function is gonna ask root. As my driver function is gonna ask the root, see what is the value, what do you want to return me? So root will say, I will have to look at the tree. I will have to look at the tree. One will say, or I can say root will say, I want answer from tree. I want answer from tree. And in the previous video of finding the diameter of the tree, I said that whenever the parent asks for answers from the children, we have to use the post-word traversal. We have to use the post-word traversal. Why? Because parent is actually using the values of the children. Parent is actually using the result of the children, right? So post order is simplified. Post order is simplified. Now let us go into the depth at how we will use the post order. So post order says it will go to 2. Okay. 2 will say, am I 6 or am I 8? You will say none. So 2 will say, I didn't find any of them. Neither am I equal to one of them. So I will say I am returning null. I didn't find any of them. I will come to 3. 3 will go for the post order and say 4. 4 will also return null because my subtree does not contain any of the node and I also does not contain any of the node. 3 will say that go to 5 now. 5 will say go to 6 first. 6 will say, see, I am 6. 6 and this 6 are actually matching. So I am saying that I will return myself. That I found 6, so I am returning myself. I found 6, I am returning myself, right? Because the left and the right are already null, so they are returning null to it. Try to think that they are returning null to it, but 6 says I am 6, I will be returning 6. Okay. 5 says let us go to the right part now. 7, 7, do you have anything? 7 will say let me explore. So 7 right is returning is null, but when it comes to 8, 8 will return 8 itself. That 8 I have found 8, I have found 8. Okay, 7 will say, see, I don't have both the nodes. I don't have both the nodes. 6 is not present with me. I just have 8. So I will just say 8. I will just say 8. But 5 says that, hey, I got 6. I got 8. That means both the nodes are actually getting separated by me. That is me. That means I am the lowest common ancestor. So I will be returning 5. I will be returning 5. 3 says null and 5. 3 says null and 5. So 5. 3 will say, okay, I will also return 5. 1 says null and 5. I will also return 5. Do you understand what has happened? Do you understand what that happened? One said it is null. One said my left subtree does not contain any node. My right subtree is giving me 5. So I will return 5. I will return 5. So what is actually happening is my function is f. I have the root. The base case is simple that if my root is equals to null. If my root is equals to null, return null. Return null. Because I don't have anything to explore, right? Return null. Second condition is what happened with 6. 6 said I will return myself. 6 said I will return myself. So if root equals to p, what is p? P is given to as a p and q are the two nodes we have to find the lowest common ancestor of. If root equals to p or root equals to q, in any of the case return the root that I have found one value. I cannot find two values, I have found one value, right? I cannot return two values, so I found one value, I am returning one value. Okay. Moving on, I will find the value from the left. My left says f of root left, f of root left, and my right says f of root right. Now there are four conditions that can come. Four conditions. First is my L is equals to null and my R is equals to null. Right? If both of them are null, that means something like this has happened, that I am 8, 9, 10 and I want to find 11 and 12. You can say that 8 will say it is also returning null. It is also returning null. Okay, I will also return null. I will also return null. So 8 will return null in that case. So return null in this case. Return null. But what if L is not null? L is not null and R is not null and R is not null. That is both of them are not null. Both of them are not null. If both of them are not null, then something like this is happening, which was happening for 5. 6 is also not null, 8 is also not null. That is, I am the lowest common ancestor. So I will return myself. I will return myself. So return the root itself. Otherwise, if L is not equal to null, so what has happened? Both of them are null. 0, 0 has happened. Both of them are not null. 1, 1 has happened. Now the cases left are 0, 1. That is right is null. Right is not null, or 1, 0. That is left is not null. So if left is not null, return left. Return left. What was happening for this node? What was happening for this node? 6 was returning itself, right? 6 was returning itself, right? Or suppose you can say 5, or you can say 3. 3 was returning 5 because 3 got 5 from the right, and it says one is null and another is 5, so I am returning 5. Okay, I have something. Okay. Now similarly, if R is not equal to null, return R. Return R. That's all. That's all. Okay, this will give you the exact answer, right? Now my question to you is, in the same tree, that is 1 connected to 2 connected to 3 connected to 4, here 5, here 6, here 7 and here 8. If the nodes given to you were 5 and 8, will the same code work? Will the same code work? I know that you might have got this question in your mind. That is why I'm discussing it. Yes, the same code will work. What will happen? One, I will go to one, but one will say first explore the left. I go to two, but two will say explore the left, then explore the right. Both of them returning null. Two is also not equal to 5 or 8. Return null. One say now explore the right. I come to 3, I go to 4, 4 also return null. I come to 3 again, I come to 5 now. 5 will say go to 6. Again null because 6 is not equal to 5 or 8. Now 5 says, hey, just a minute, I don't want to go to 6. 5 will say that I am 5, I will return myself. I don't care about 8. I am returning myself. Why? I am returning myself. Okay. Now 3 will say that null and 5. Okay, I will return the not null one. One will say null and 5. I will return the not null one. Okay. So answer is 5. And if you see, the answer is also 5 only. The lowest common ancestor of 5, 7, 8 is 5 because the path of 5 is 1, 3, 5 and the path of 8 is 1, 3, 5, 7, 8. So if I try to find the first node which is common, it is 5. It is 5. It is 5. Also, I forgot to mention in the starting of the video, this is the brute force approach, guys. This is the brute force approach. Find the path of the two nodes and then compare the first value which is common to them. Okay. Okay, so sorry to forget it, right? Now I would like to write the code for it. I hope you are clear with it. The main problem I want to tell you is that whenever you are using the value of the children, this approach, whenever you're using the value of the children, you have to use the post or a traversal. Please keep that in mind. This is very important to crack the OS. This is very important to crack the binary tree questions, right? Now let us move to the code. So here is the coding section, guys, but before starting with the code, I would like to request you to please subscribe to my channel because it really means a lot to me, right? Now moving on, first what we will do, let us write the code here only, that if my root equals to null, return null. If my root equals to null, I will not be able to do anything. Otherwise, the second condition is if my root equals to p or root equals to q. That is, if I found any one of the root, return root, right? Now get the root from the left and right. So tree node star lel equals to, let me copy down the name of the function. It is lowest common ancestor for the recursive call of the root left with p and q, right? And similarly tree node star r is equals to lowest common ancestor of root right with p and q, right? Now the three cases arises if L and R, both of them are not null, return root, because this is my answer. If L is not null and R is null, in that case return L. If R is not null, return R. We discussed it, right? Otherwise, if L and R, this is the only case left, you will return null, right? You can also skip this condition because this is the only case left. It will run automatically if above three conditions are not running. Let us try to compile and run it. Hope it will work fine and should not give any error. It is working for the sample test cases. Let us try it for the hidden test cases as well. It is running and it is getting accepted. So thank you for watching. Hope you liked it and we'll meet again in the next video. Till then, stay tuned and do not forget to subscribe and keep coding. Thank you. Have a nice day.